Alright, this video demonstration is going to cover the Core Learning Goal 1.2.5, which has matrices and formulas. Alright, so the first two questions will be matrices, and then the last three questions will be with formulas. So, matrices. The only thing you need to know how to do with matrices is identify what you're looking at within the problem, and then determine if it's addition, subtraction, or scalar multiplication. That's it. So, we see a problem that says the store sells t-shirts. The matrices show the number of shirts that are in the store on November 1st and December 1st. So what that looks like to me is, if I'm looking at this one right here, the small shirts, where it's 100, and then in December 1st there's only 40 of them left, so that tells me that they're counting the ones left to determine how many they've sold. So, and that holds true for all the rest of them. So the medium white shirts went down, the medium gray shirts went down. Alright, so it's saying if the store did not add any additional t-shirts, so there's none that came in on a shipment between November 1st and December 1st, what size t-shirt sold the least? So what size? This is the key wording right here, and this is where they're going to get you every time if you don't pay attention to the thing. Size, t-shirt. So it doesn't say what color size, it says what size. So it's white and gray shirts put together, okay? What ones sold the least? Well, on November 1st, there was 250 smalls, there was 310 mediums, there were 390 larges, and there were 440 XLs. On December 1st, there's 140 smalls, 230 mediums, 180 larges, and 280 larges and 290 extra larges. So I want to determine which size sold the least. So which one went down the least amount from November to December? Well, the smalls went down 110 shirts. The mediums went down 80 shirts, subtracting 310 and 230. The larges went down 110 shirts, and the XLs went down 150 shirts. So we look at the mediums had the smallest decrease, so that means they sold the least as well. So the answer is G, medium. And that's the kind of thing you got to ask yourself with this. What are they asking? What size t-shirt sold the least? So size, meaning the color doesn't matter. So to find out all the color, and then subtract to find out which one sold the least. Alright, the matrix below shows the grades on an algebra test and a science test for 3 different students. Lauren, so we already know that we don't care about Leo or Anthony, increased her grade on the next science test by 5%. With this grade, what was her grade on the next science test? Well, to increase anything by 5% means that you have to either A, multiply that by 0.05 and then add that amount back onto the original test score, or just multiply that test score by 1.05. And we use the calculator. So we have 80 times 1.05, 84. So her next grade on her science test is 84, and we would bubble that in because this is an SPR. Alright, the teacher uses an equation to predict the letter grade that a student earns. This relationship is shown below. So there's the table, that's what grade they get if their grade falls between this. I'm sorry, read the whole question. This data shows a relationship between the number of student absences and the grade that they can earn. So there's a negative sign here. They take away 0.25, maybe it must be of a letter grade, for every day x that is missed, and the grade is the result of this equation. Alright, so we want to take a look at what's the letter grade for a student that has 4 absences. Well, we'll just take our equation, and since we know the number of days absent, we're going to substitute that for x, which stands for the days absent. Okay? We don't really need the calculator for this. This is 0.25 or a quarter, so 4 quarters is 1, a whole dollar. So we've got a negative 1 plus 4, which is 3. So I know that that student has a 3, or a 3.0. And the 3.0 falls in the B category, between 2.5 and 3.4. So this student gets a B for missing 4 days. Sally has a copy machine. Machine ages increase as the machine ages. As the machine's age increases its value and dollars decreases. So as the age goes up, the value that it has attached to it goes down. It's called depreciation. The equation is used to calculate the depreciation for this copy machine is shown below. Y is the amount of money, it's the depreciated value that it's worth, and after however many years it's been around. So it starts out at being $7,000, and for every year that it ages, it gets to be worth $500 less. That's how this works out. So what is the depreciated value of the copy machine after 5 years? Well, it's not going to be anything with other than on the whole thousands of dollars or something 1,500, because that's what you're multiplying by. So A is not it. Alright, so after 5 years, how much is this thing worth? Well, it goes down 500 every year for 5 years, and we had it starting out at 7,000. So 500 or negative 500 times 5 is negative 2,500, or basically it's lost $2,500 in value from $7,000. Okay, so that is 4,500. Alright, so since it's started at 7,000, it's lost $2,500 in value. So the remaining value, it's now worth $4,500. In a mathematics class, the formula below is used to convert the number of points scored on a test from a raw score to an adjusted score. Alright, so what's the adjusted score if the raw score is 64? So I think this is kind of talking about a curve to a test. Scores are lower, so we use this formula to curve it up a little bit. Alright, so it says the raw score, R, is 64. Well, we just make a substitution again. Alright, now we could do one of two things. We could use the calculator and we could put 7/8 into parentheses, which is probably the easiest way to do it. Or if you know the value of 7/8, you could use that decimal form. Alright, so we'll go to the calculator. We have 7/8 times 64 plus 20. Notice I just type it like I wrote it on the page. That's all we need to do. The calculator can handle that representation. Alright, we find out that the adjusted score, or A, is 76. And there's not really a whole lot you can do unless you want to go through, I don't know, and determine what seems reasonable. You know that 7/8 is pretty close to 1. So adding 20 to 64, if this was a whole number, if this was 1 times 64 and we added 20, the most it could be is 84. So we know it's not C or D. So it's going to be between A or B. That's about the only thing you can eliminate on that. And that is basically matrices and formulas kind of wrapped up. So that's the end of this section.